So today I'm going to be talking to you all about the cloud. Presentation, of course, being called Embracing the Cloud, and I'm hoping by the time that we finish with this presentation that you will have embraced the cloud. Autodesk has a great many cloud applications that can be very beneficial regardless of the industry that you're in, and I just kind of want to make you aware of them so that at least you know that they're available to you and there to you. Maybe there'll be a couple that sound like something that would be great for you to add into your design process. And then I'm also going to talk just about the cloud in general, just to make sure you fully understand what the whole cloud, what does it really mean, right? So about a year ago, actually a couple of years ago, Autodesk came to me and they said, okay, we want you to go out and we want you to talk all about the cloud. And I said, okay, great. I guess I should learn something about it. So I've been on this massive search for as much information as I could get about the cloud, trying to get all my questions answered. Because clouds can actually, this whole cloud concept can be a little bit confusing. For example, I mean, there's all different types of clouds, right? There's like point clouds, there's revision clouds, there's these warm, fluffy clouds, and then there's all this software that's supposed to run on the cloud. So it kind of reminded me of the Joni Mitchell song, which some of you might remember, Cloud Illusions. I recall, I really don't know clouds at all, or sadly, Joni Mitchell apparently is having health problems right now. But I'm sure she'd love to know that we were quoting her. But it is a little confusing. And so the very first question I set out to ask myself was, well, why do we call it the cloud? You know, why don't we call it the sun or the moon or, I don't know, the carpet? The granola bar, I don't know, why do we call it the cloud? How did it get its name? So I'm going to tell you why. I found the answer, thankfully, after a bunch of research. We call it the cloud because of this gentleman right here. He was a Stanford professor named John McCarthy. He's known as the father of cloud computing, and he made a statement back in the year 1961, if you can imagine. He made a statement that someday computation would be organized in the same way as a public utility. And you're like, well, what does that have to do with the cloud, Lynn? We'll get there. So what he kind of meant by that was that we would access our software the same way that we do our utilities. It's like if we need electricity, right? We plug in or we turn on, and if we don't want that electricity anymore, then we simply unplug it, right? And that's kind of the same way cloud applications are. You basically, as long as you have an internet connection, you can access those applications, and you don't have an internet connection, well, let's face it, you can't, right? So when he was first talking about this whole concept about how we were going to access our software the same way that we did our utilities, remember in the early days, of course, the utilities was all about the network, still is all about the network. This is an example of a telephone network in the early days. He was specifically referring to the telephone industry. And in the early days of the telephone industry, the network, or the telephone industry, was called, ta-da, a cloud. so all because of that great big long story is the reason why we refer to this technology as the cloud, believe it or not. So it's kind of a long way to get there, and you know, I'm not sure how exciting dinner conversation this would be, but at least now you know if you guys happen to be on Cloud Jeopardy, you know the answer, right? So it's all because, once again, of this gentleman right here. And then I thought that just a little trivia for some of you who've used AutoCAD for a while. He's also the man who invented the programming language Lisp, which we, of course, morphed into AutoLisp. And some of you might remember, at least from some movies, back in the 60s, he was the very first person who wrote the software program that allowed you to play chess against the computer. So he's known as the father of artificial intelligence, brilliant man, did a lot to push us forward in computers, and brilliant man. So here you go, more trivia for you. So what does the cloud look like? Let's keep going. Now we know why we call it the cloud. What does it look like? It doesn't look like this, right? It really looks like this. If you have a better picture, a little more realistic picture there. So there are over 60 million servers worldwide that are being used for cloud applications. These are serious servers, right? Very robust, very fast. And, you know, if you're using cloud applications, you are no longer restricted to whatever hardware your boss decided that you were worthy of. You actually can access these servers, especially, which is really important when it comes to doing complicated things in design. And then I just threw in a little quote down there. 84% of the CIOs report a cut in application costs when they start to move to the cloud. So you save money ultimately as you start to make the move to the cloud. So there are 3 primary reasons to use the cloud, I should put, according to Lynn. This is what I came up with in all of my research, and this is what I absolutely believe are the 3 categories about why the cloud can help us in the design process. So the first one, super obvious, storage and access to data from anywhere, the mobile app. You guys totally get that, right? You can access your bank account from anywhere. You can access data. You can transfer data. The total cloud application. You can store your photos up in the cloud. You can store all kinds of information and files up in the cloud. And you can access that data from anywhere. And another reason why you would use the cloud is the collaboration aspect, which is fantastic for design, because no longer are we limited to collaborating with the people in our office. We can collaborate with people all over the world as long as they have an internet connection. Very, very powerful. Opens so many doors. And then last but not least is the computing power aspect of the cloud, which I personally think is the most valuable of them all, because this allows us to do things that we would never even think about doing before, like simulation, for example. Most of us would never think about simulating maybe an environment in a hospital room, for example, because it would be so complex, and our computers just can't handle it. But those servers, those 60 million servers, can certainly handle it. So being able to really have more computing power at our fingertips, as long as you have an internet connection, regardless of the hardware that you have. So let's talk about these a little bit. So for the mobile app, I think everybody gets the mobile side of things, right? We totally get that. We've been exposed to it for quite some time. Most of you who are listening probably have smartphones. A good percentage of you have tablets, and they've allowed us to be very, very mobile. And it's believed that the tablets of today, which, like I said, I'm sure many of you have, has about the same computing power as our workstations did 10 years ago. Interesting, right? We were certainly able to do our designs on our computers 10 years ago, so we have quite a bit of computing power in those little tiny tablets. And it's also believed that perhaps at some point in time, the workstation will become our the tablet will become our workstation of the future. I can assure you that our next generation certainly thinks that. They use them all the time, right? It's second nature to them. And just some more facts for you. The iPhone 5 has more brain power than the Mars rover did. That's a pretty amazing statistic. And that back in 1969, they had less computing power than we also have on our iPhone 5. Not even the 6, just the 5. They were able to do amazing things with that much power, right? And here's an example of, and I'm hoping you can all see this video. It's a cute little video of a girl who is very, very comfortable with the tablet, as is many in our next generation. And then she's kind of trying to figure out this whole magazine thing. She's not really sure what the allure is, why she'd be interested in a magazine. Doesn't seem to be working, for one thing. Can't quite zoom in. Getting a little frustrated. This is my favorite part. So she's thinking, you know, maybe my finger is the problem. Maybe it's not the magazine. Maybe my finger is the problem. No, my finger seems to be working just fine. So, you know, that's really the next generation. They're going to expect to be mobile. They're going to expect their computers to be very lightweight, be able to get them anywhere they need to take them, and they're going to expect them to be very robust, lots and lots of power. So, and this is just to kind of show you how progress has changed over the last few years. This is back in 2005. This was the inauguration of the Pope, if he's inaugurated or ordained or whatever. This kind of shows you that there's really just like 1 or 2 smartphones. You can see that at the very front, one on the right and one on the left. That was in 2005. Now take a look at the way it looked in 2013. Look, everybody's got a smartphone or an iPad. Drives me crazy when someone holds up an iPad, does it drive you crazy? I'm trying to take pictures with it. So technology has definitely changed. Mobile technology, we almost all have it. And I thought I'd also share with you the way we've adopted technology over the last 100 years, really. You can see the telephone, which kind of pulls back to what we were talking about earlier. The telephone was very, very important, of course. I'm not sure who sold the first one because, let's face it, who could you call? I'm sure he was a really good salesperson. You can see it took a while for people to really jump on the whole telephone bandwagon. In 40 years, only 40% of the people really access that telephone technology. And here's some others. You can see electricity, people got that right away. People wanted that right away. Refrigerators, they were so over the ice, they got that right away. But you can see that for the most part, it still took quite a bit of time for people to jump onto technology. People thought about things differently back then. They wanted to make sure that things worked before they would buy them. So they waited for those, those brave ones, those cutting edge individuals. You see the color TV, that's an easy sell. We already had black and white TVs. Easy to switch people to color TVs. There was a clear advantage and no fear of technology there. I totally don't understand the dishwasher. What's up with that? That would be in my top 10. I'm just saying. People didn't get that? I totally get it. But if we keep going to the very end of this chart, take a look in the last 20 years, even the last 10 years, look at how fast people adopted things like Facebook and tablets and smartphones. I'll just pull that out so you can see that even more clearly. But you can really see that now people adopt technology very, very quickly. They expect a lot out of their technology. And they don't wait now for someone else to buy these products first. They just jump in with both feet. So technology adoption has really changed a lot. Now this is a mobile application called BIM 360 Field by Autodesk. This is showing a man who is out in the field, contractor out in the field. He's taking a look at a pump, making sure that there aren't any issues with that pump, and can actually get to the point where he can see the model of the pump and how the pump was supposed to be installed. Now, if you take a look at the construction industry, about 90% of all the technology stays in the trailer. It stays in the office. We're trying really hard to get that technology out into the field where it belongs. And this is a perfect application. It works on tablets to get some of that information out to the field. We don't have to carry all those great big huge books around, for one thing. So BIM 360 Field, if you're in the construction industry, you might want to take a look at that fabulous program. All right, let's move on to collaboration. So that was kind of talking a little bit about mobile. I know you guys all get that. Let's move on to collaboration. So I'm hoping that many of you have an A360 account. If this was a live audience, I'd ask you to raise your hand. I can't see you, so for all I know, you're tweeting or doing your email right now anyway. So everybody who has, well, actually, even if you don't have an Autodesk account or product, you can open up an A360 account. It's actually free for everybody. But you will see that A360 is incorporated into our main products like Revit and Civil 3D and AutoCAD and Inventor, for example. It's really integrated nicely into those programs so you can easily get to your A360 account and take advantage of having an A360 account. Everybody who wants an A360 account gets 5 gigabytes of storage, and those of you who are on subscription, you get 25 gigabytes of storage. And I'll say at the very lowest level, and this is the very lowest level, and I'm sure the A360 team would have a heart attack if they heard me saying this right now. But at its lowest level, it is like an awesome backup program because you can set it up inside of your software. Let's say you're using Revit, so that every time you do a save, it automatically saves to where you normally save. Maybe that's your local hard drive, maybe that's your network. But it also saves to your A360 account. No questions asked. You don't even have to think about it. It just magically does that. And then let's say you're going the next day and you get sick, but your boss wants you to make a couple changes to your Revit model, and you have access to it, right? Because it's in your A360 account. You can actually, from home, you can log on, you can get that model. You can just send it to him directly if you don't want to fix it yourself, or you can open it up on your system at home and make those minor changes, and then send that off to him, share a link with him so he can go in and he can get your model and see the changes that you've made. So it's basically access to your design files from anywhere. Okay, so that's at its lowest level. It also allows you to share your designs with your project team. You can put all different types of documents up there. They don't have to even be Autodesk documents. You can put your grocery list up there if you want to. But it allows you to do much more than that. So what we're looking at here is a 1.5 terabyte Revit model. This guy's big. And it is zooming around and panning around and viewing it in real time. We didn't speed this video up or anything like that. So you can also take a look at models in A360. In fact, you can share your models with anybody, even if they don't have any Autodesk products. You would, like a building owner, for example, you could share this with them very, very easily. You'll notice that as it spins integrity, because it's, well, let's face it, it's a big file, right? But as you stop, it fills in all the gaps and looks pretty darn good. This is taking advantage of some of the showcase technology. Now we have some great visualization products at Autodesk, and that's why we're able to zoom around it very quickly and see it very clearly. So on the same idea, we want to be able to look at our files, but we also want to be able to get information from our files. We want to mine some of that data so that we can access it. And once again, you could share this with anybody, and they can go in and they can take a look at the information that goes with the model. Amazing technology. And then some of you may have used AutoCAD 360. I bet you that over 20 million downloads is wrong now. That number changes all the time. I can't keep up with it. But for those of you who are still integrated into AutoCAD, there is a tablet app that you can use that allows you to take your drawing files anywhere you want to. It has some basic markup capabilities on it. It can do dimensioning. And because tablets have GPS built into them, you can actually drop a marker in your drawing file when you're on site in the exact location where you are standing on the site. And it would actually know where you are at any point in time in the drawing file. It's amazing technology, really great technology. You do not have to have an internet connection to view your drawings and mark up your drawings, but if you do, you have some added capabilities of what you can do. And you can also go to Autodesk 360 through your web browser, where you'll find even more capabilities, where you can share your AutoCAD drawings with people that don't have AutoCAD. And you can even let them do some basic markups. So yeah, take a look at that. Look up AutoCAD 360. You'll get quite a bit of information on that for those of you who are still working with AutoCAD files. So here's another one of our fabulous cloud applications. This is BIM 360 Glue. BIM 360 Glue allows you to take more than 50 different file types. Once again, they don't have to be Autodesk file types. Put the models together. This is more specifically for BIM, for building information modeling, and then coordinate and check for clashes. Makes it much easier for you to collaborate as a team. And you'll see that as these clashes occur, of course, anything that's red is bad, right? For some reason, red is always bad. You can send an email to the team, and you can let them know that there is a clash and that you need them to fix it. And then the team themselves, they don't have to wait for you. They can go back in and make sure that the changes that they made don't create any additional clashes, because that does happen a lot, right? So this is BIM 360 Glue. Once again, supports over 50 different file types, lets you take your model, put it together, and then check it out and make sure that there aren't any clashes. So my favorite part, right, about the cloud, this is where I think the most valuable aspect of the cloud comes into play. When you're dealing with large amounts of data with lots and lots of variables. So if you were to run just an average size computer, just a regular your average Joe computer, not an amped up one, but if you were to run it for 10,000 seconds, it costs about a quarter. If you were to run 10,000 computers for 1 second, it costs you about the same amount. Now, if I'm drawing lines, arcs, and circles, that first option is perfect. But if I'm doing something complicated like energy analysis or simulation, well, that's when I would really like those 10,000 computers working for me, as opposed to just that one with that very little computing power. So I took this picture while I was in South Africa. This was in a university. It's a real-life picture that Lynn took. And this was, of course, if you've ever done rendering, I'm sure many of you have out there, this was a student who didn't want anyone to touch the computer for fear that they would mess up their rendering, which later I was told took a couple of days to do the final render. And I'm sure many of you have been in this situation. Rendering requires a great deal of computing power, and consequently, when you try to render on your computer, it can take a great deal of time. It can take hours, it can take days, it can take weeks. So, perfect cloud applications, absolutely perfect. You take the information that you need to do the rendering, you put that into the cloud, you put that into A360, and let all of those servers do the work for you while you continue to lead your design life and go on and do the other things that don't require a lot of computing power. Your computer will not be slowed down like it would if you tried to render on the computer itself. You just sit and wait. And something that used to take 24 hours in the past, now you're down to less than 24 minutes. When the rendering is finished, you get an email with a link, you click on the link, and there you got it. You know, given all of the information that you gave it, it will create that perfect rendering. And then I just have it in there because it's so cool. I hope you can see it the way I can. Water's so hard to do. I just love it. Beautiful rendering. So many of us communicate our design to other people, right? We either are trying to win projects, we might be trying to win a community over, or just trying to get our ideas across to maybe people that work with you. And many of us do things in 2D. And not everybody in the world understands 2D. It's much easier when you have a visualization in 3D, a true-to-life visualization. And in the upper right-hand corner, this visualization was done by InfraWorks 360. And they're trying to show this new roadway that they want to build. That would be so much easier, that bridge, so much easier for people to truly understand their vision of how they want to design that bridge. Am I right? I'm going to show you a little bit more with InfraWorks 360. It's such an amazing program. I love this. So if you're doing in the business of doing roadways or bridges, anything like that, this program is fantastic. You literally just type in an address and it will populate the surrounding area with buildings, basically. And you can even add more if you want to. You can find quite a bit of information already out there in the world to populate this particular, any neighborhood with. And then you could go ahead and put your design in there. Let them see how it's going to look in the actual area where you want to build it. Amazing technology, very simple technology too. Because if this wasn't hard for you to do, right? If this wasn't hard for you to do, you would totally do this in a proposal, right? Because it's so impressive, and you know anybody who puts that in a proposal probably going to win. Be very clear to all the stakeholders what you're trying to accomplish. So this is also using InfraWorks 360, but it's showing putting a Revit model of a stadium in the actual location where the stadium is going to go. Very clear to all the stakeholders. Everybody knows what it's supposed to look like. And you can see exactly what it's going to look like in the neighborhood. So take a look at InfraWorks 360. Fabulous. And then not too long ago, we came out with collaboration for Revit. Those of you who work on Revit files, you know that usually the main model lives on a server somewhere, and the BIM manager is the king of the server, and he gives people access or doesn't give people access. But in order to work with design teams that are all over the world, it can get a little complicated because they all have to have access to that model, right? So collaboration for Revit is great because it allows you to, as long as you have an internet connection, you're going to put that model up in the cloud, and anybody that you want to have access to it can get to it. You can connect the entire project team. And I have a good friend of mine who was in the beta group for this. He says this is just a huge game changer for them. He works for Stantec, big company, and how this is going to really revolutionize things. So if you're collaborating with other people, not all in the same building, definitely take a look at collaboration for Revit. So we're going to move on and talk about point clouds. I love point clouds. This is kind of confusing, right? We have the cloud and we have point clouds. What you see in front of you is a bunch of pictures. Somebody went out and took a bunch of pictures of that building, and then using our technology, putting those pictures together to get this 3D model of a building. I can assure you there are no floor plans for that building, right? We don't have a DWG or a Revit file for that building. It's a very old building. But you can see the power that we have, even just taking pictures in creating a final image or a final solid model. Very, very impressive, right? Let's talk just a little bit about point clouds and recap. All of you, when you installed any of our main products, you know, like once again, Inventor, Revit, any of the Revit products, Civil 3D, AutoCAD, you saw that we requested that you download Recap. You may or may not have done so, but it's completely free. It comes with your software. And the goal behind Recap is to take those point clouds, which could be made up of billions of points, and then to streamline them, make them easier to work with, put them together so that you can bring them into your product, bring them into Revit, bring it into AutoCAD. And point clouds, because they contain so many points, can really slow you down, billions of points. And you can only imagine if you just bring billions of points into Revit that you're definitely going to go slower. So Recap goes in there, straightens them all out, you know, streamlines them, makes them smaller, makes them easier to work with. And, you know, this is an example of a tech shop that we have in San Francisco. This is a point cloud, and we just want to make a couple of additions to the point cloud. You know, we don't have the floor plan for some reason, and we don't want to have to go in and measure all this information just to add a wall and a door, and we're lazy. So in a little bit, we'll go in and we'll add that wall and the door without having to really draw much of anything inside of Revit. So typically we do start with a blank sheet of paper, right? We start with an empty screen. Sometimes we do, sometimes we don't. But everything in the real world starts with an existing environment. So why not capture that environment and, you know, use your design in context? And just to kind of show you how much we've improved over the past few releases. Back in 2013, if we were to bring in a point cloud, it looks like what you'd see over on the left. You can only bring in 2 billion points. It would be very slow as well. It would be very slow and very tedious. As soon as in the next couple of releases, we were able to streamline those point clouds by using Recap. We're able to bring in over 20 billion points now, and look how much better they look. It looks almost like a photograph. It looks so realistic. So here we are back in our tech shop, and we're going to go in and we're going to add in a wall and a door without ever having to measure anything, because point clouds are incredibly accurate. You get them, of course, from scans. You scan rooms or buildings or whatever, pick your object of choice. You can snap to the points. In fact, AutoCAD added like 5 new object snaps this year to snap specifically to point clouds. You can do dynamic UCS on point clouds now. But you can see they were able to very quickly put in a wall and put in a door without ever having to draw anything else related to the building. So there you have a mixture of Revit objects and a point cloud. Think of the possibilities. So we also got together with GoPro. Of course, why not? Who wouldn't want to get together with GoPro, right? And this gentleman decided that he wanted to do something with this bunker. It's been in San Francisco for quite some time. Obviously, with the bunker, there are no floor plans. You don't have a Revit file for it, but it's prime real estate, so why not finally do something with it that maybe can add to the community, or maybe an amazing restaurant, or who knows what they might decide to do with it. So he decided to scan it using his GoPro, scanning it, and then this gentleman had only used Revit for 2 days, which I think is pretty impressive. So you might see a couple of tiny little errors in the elevations, but you will see that he came up with a pretty impressive model just by scanning it without having to draw anything from scratch initially. So this has some very loud music. So if you're sitting in your office next to somebody, I just want you to brace yourself. You'll probably have to turn the sound down. You probably already did anyway, because I'm probably talking too loud. But so just hold on. It starts off quiet. There's no noise right now. Just some profound thoughts. And then it will totally wake you up. See? Okay, it's on over to the dog shows up. He had his little quadcopter and he flew all over so he could get the top of the building, scan the top of the building, and then put it together. I think he did a really great job. So that's the power of adding in a GoPro with recap. So the biggest cloud fear, of course, I don't know if you could hear her scream or not, but I'm sure you're all thinking about the security issue. I'll absolutely tell you that the cloud is more secure probably than your office. I can only imagine that somebody could at some point in time come in and grab a USB and get the information out of your office in some way. And that we use the same technology, the same very, very tight, secure technology as our banks. And I like to think that our banks are secure. I like to believe my money is secure. So we're very careful, very, very careful with all of those design files that you have so kindly put up on A360. And if you think about it, and incidentally, you have access to them, we don't, just so you know. We can't, they all belong to you. If something does go terribly wrong, Autodesk would be in a really bad shape, right? Because we believe that the future, so much of the future is going to involve cloud technology. And if we don't get it right, if something goes wrong, we're going to get kicked out of that business before we have a chance to really see all that it can do for the design process. So as a result of that, we spend a great deal of money making sure that A360 is very, very secure so that you guys can be confident that your designs are safe. And I actually heard someone say this quote about a month ago, a couple of months ago, and I know some of you can't use the cloud. Some of the government's still trying to figure out if they're going to allow, start to use cloud technology. Some branches of the government have started to use it. Some companies haven't started. There's a bunch of different rules for the different companies that you work in. But I love this quote. Your company may embrace the cloud or your company might reject the cloud, but one thing is certain, that every single company is using the cloud, at least in some way. So I dare you to find me a company where there's no cloud usage at all. It's just basically, we're all using it. We may not be using it for all of our designs, but somewhere in your company, somebody's using cloud technology. So I'm hoping that I'm going to just wrap here with some of the advantages of using the cloud, but I'm hoping that I showed you a couple of applications that you think will be valuable to your company that you might want to look at further. Certainly talk to Microsol about that. They'd be happy to help you out. But just kind of an overview of some of the advantages, once again, of using the cloud. Imagine never needing to install new releases or versions. I know that some of you CAD managers love that part of your job, right? Where every year Autodesk comes out with new releases and then you have to deploy it. It's like so painful. So if everybody was using a cloud application, and let's just say maybe it was Revit, if everybody was able to go online and use Revit and it was a good experience online, every time any new release came out, it would automatically happen in that cloud application. It would be completely invisible to the user. So you wouldn't have to continue to install new products. Plus, then everybody would be on the same version. How fabulous would that be? How many times have you had to deal with people that are not on the same release as your software? It gets very complicated. This would ensure that everybody was on the same release. We would all just go online. We would access Revit or AutoCAD or Civil 3D, whatever the situation was. Now, we're not there yet, but we're getting very, very close. And so much of it, of course, also has to deal with bandwidth. We want to go fast, right? We don't want to go slow when we're using Revit or when we're using Civil 3D. We want speed, speed, speed. So we're not quite there yet where we have a full-fledged cloud application that for all of our products, like Revit, for example, that I promise you we're working on it and that someday we're going to get there, that we'll be able to just run on the cloud. A couple of other things, of course, the ability to save in some heavy computing tasks, do things, once again, like simulation, energy analysis, anything that's very complicated, things that before we wouldn't even try to do on our computers, now we can do because of the power of the cloud. And that true collaboration element, like I showed you that Revit for collaboration, where we can work with people all over the world on the same model. So great capabilities. And once again, I'm going to emphasize how safe and secure the storage is. And the Autodesk has gone to great lengths to make sure it's all incredibly secure. So on that note, I'm hoping that I convinced some of you to embrace the cloud, or at least opened your mind a little bit to this cloud technology. And I want to thank Microsol for being so kind to invite me to do this presentation, and for all of you, once again, for taking time out of your days to spend being educated about the cloud.